All right, in 8.2, we're going to look at systems of equations again, and we're going to solve by what we call elimination. All right, so first I want to talk about the difference between consistent and inconsistent systems. If a system has at least one solution, it is said to be consistent. Okay, notice at least one solution. Can have more than one, at least one. So if it's consistent, there's two options. If it has exactly one, it's called independent. Okay? If it's consistent and has an infinite number of solutions, it's one of these two, then it's called dependent. All right? So exactly one is independent, infinitely many is dependent. So a consistent independent system would look like this guy right here. One interaction or one intersection of the two graphs makes it consistent because there's one solution and it only crosses one place. If it is infinite many solutions and it's called dependent, that would look like this. Basically what that means is that it's the same line. They have the same slope, same y-intercept. It's dependent. They depend on one another because they're sitting on top of one another. All right? Then, if it has no solution, we call it inconsistent. The graphs of the lines do not intersect, so the graphs are parallel, and there's no solution. So that's this picture right here. That's what's going on. So as we solve these today, we're going to label them as consistent or inconsistent. And if it's consistent, we're going to label it as independent or dependent. All right, so first, look at this system. We want to solve by elimination, which means we get rid of one variable. It doesn't matter if you want to get rid of x or y. The method works the same. So I look at my coefficient. I'm going to work with x. I want to get rid of x. So I have 3 x's down here. So to get rid of 3 x's, I need to take away 3 x's. So I'm going to multiply this top equation through by -3, distributing the -3 to all 3 parts. So when I do that, I'm going to end up with -3x minus 3y equals 0. All right, that goes to 0. 2y minus 3y is -1 equals 1. 1y, sorry. So if I solve for y is equal then to -1. Okay, that's great. Now I take the original equation and I plug in what I got for y and solve it. Well, if x minus 1 is 0, that means x is positive 1. So it looks like my solution is 1, -1. So you can always go back and check, plug in your numbers. 1 minus 1, is it equal to 0? That is true. 3 times 1 plus 2 times -1, is it equal to 1? Well, that's 3 minus 2 equals 1. So that is a good solution. Now, we have one solution. So we have a solution, which means this is consistent and it is independent. There's only one solution. We'll do an example that has more than one, so you'll see what that looks like. But if you end up with a clear x and y, that's just an independent, consistent system. Let's try this one. Again, I want to eliminate a variable the easiest way possible. So I look at my x's. There's -2 down here. There's 1 here. So what do I need to do? Multiply through by +2. When I do, I get 2x minus 2y equals 4. Then I combine like terms. -2x plus 2x is 0. 2y minus 2y is 0 equals 5 and 4 is 9. Well, that is not a true mathematical statement, right? So this means there's no solution. So our fancy word for that is inconsistent. Inconsistent system of equations. All right? Let's try another one. All right, again, I want to get rid of a variable. I'm going to choose x again. Not that I have to, but I'm going to, because I can see a clear way to get rid of this. If it's -6 here, I need this to be +6. So I'm going to multiply through by 2. When I distribute that, I get 6x minus 4y equals 10. Okay, so -6 plus 6 is 0. 4y minus 4y is 0 equals Negative 10 plus 10 is 0. All right, so this is still a true mathematical statement, right? But x and y disappeared. So what does that mean? That means that this is consistent and dependent. Okay, that means that this line, these two equations are basically the same line on the graph. Okay, they have infinitely many solutions. Now I want to rework this just so you can see that if I went about this another way, I would end up in the same place. All right, let's say I want to get rid of y. Well, I have 4y here, so I need to multiply through the top by 2. Well, that, again, would give me the same thing I just did, right? You'd end up in the same place with a consistent dependent function. All right, let's try another example. All right, this one's got decimals in it, so I want to get rid of the decimals. That's my first step, make life easier. So I want to first, like this is to the tenths place, so if I multiply through by 10 on this top equation, that'll get rid of all my decimals. So I'll have 18x plus 12y equals 40. Now if I just bring this one straight over, let's look at this and see what can I use to eliminate a variable. All right, so if I take this and I multiply my, let's do the bottom equation. If I multiply through by negative 2, I'll have 18x plus 12y equals 40 minus 18x minus 12y equals negative 6. All right? So this one comes out 0. That's 0. So 0 equals 34. Well, that's not a true mathematical statement. So automatically, we have an inconsistent function. It's an inconsistent system, I should say. Right? Last example. Oh, look, we got fractions. So let's get rid of our fractions. That's the first thing we want to do before we want to dive into elimination. So to get rid of your fractions, I would recommend let's multiply through by our least common multiple. Well, what's the least common multiple between 5 and 2? That would be 10. So when I multiply through by that, it gives me 20 over 5, which is 4x, and then 30 over 2, which is 15y equals 40. Okay, and the bottom, what's my least common multiple between 10 and 4? Well, that would be 20. Okay, so 20 tenths is 2x, minus 64ths is 15y equals negative 40. All right, so look, we already have a variable that it's almost going to eliminate itself, but what do I need to do? I need to get one of these negatives. So I'm going to multiply my second function right there by negative 1. So I have 4x minus 15y equals 40. So now I have negative 2x plus 15y equals positive 40. All right, let's clean it up. 4x minus 2x is 2x. Negative 15 plus 15 goes away, and this is 80. Divide by 2, x is equal to 40. So now I do back substitution. Back to, I would choose one of these equations up here to solve it for y. Like, I don't know, use this first equation. So I'll do 4 times 40 minus 15y equals 40. 160 minus 15y equals 40. If I move that over, this becomes negative 120. If I divide by negative 15, y is equal to 8. All right? So I can come back and check my answers if I want. So that would be, yeah, that'd be 160 minus 120 equals 40. That is a true statement. In the second equation, that would make it 80 minus 120, which is negative 40. So that's a true statement as well. So this has a solution. Oopsies. 40 and 8 is my solution. So since it has one unique solution, it is consistent and it is independent. Okay? Hope that gives you some ideas of how to do elimination and also an understanding of what consistent and inconsistent means. Okay, we'll see you in class.